Hello, everyone, and welcome. I'm excited to be here today to talk about an important topic. What is infiltration and inflow, or I in this presentation? We'll explore how unwanted water can enter our wastewater systems and why understanding this is crucial for communities everywhere. We'll cover what I is, why it matters, and what we can do about it. So, let's get started and learn more about this essential issue. Let's take a closer look at understanding I, or infiltration and inflow, and why it matters. Infiltration and inflow refer to groundwater and stormwater that find their way into our sanitary sewer systems through unintended pathways. Now, it's important to emphasize that this water isn't domestic wastewater. It's essentially clean water that shouldn't be there. When this extra water enters the system, it dilutes the sewage, which can cause some serious issues. This dilution doesn't just make treatment more difficult. It can also lead to overloads in our sewer systems, putting additional stress on infrastructure. When clean water mixes with sewage, it creates a cascade of problems, not just for treatment facilities, but also for taxpayers who ultimately bear the cost of these inefficiencies. Understanding these basic concepts helps us grasp the bigger picture of why managing I is crucial for maintaining effective, cost-efficient wastewater treatment and protecting our communities. Let's take a closer look at the difference between infiltration and inflow, as understanding these is key to managing sewer system issues. Infiltration happens when groundwater seeps into the sewer pipes, usually through cracks, broken joints, or defective manholes. This process occurs continuously, so it's a slow and steady flow of water coming from underground sources. On the other hand, inflow is quite different. It involves stormwater entering the sewer system through direct connections like sump pumps, roof drains, or uncapped cleanouts. Inflow tends to happen during rain events, leading to event-driven spikes in flow that are rapid and high in volume, and these usually come from surface water sources. Both infiltration and inflow can significantly increase sewer flow, but they differ in their sources, flow patterns, and how we detect them. Recognizing these differences helps us identify the right solutions to keep our sewer systems functioning efficiently. So let's talk about how I, or inflow and infiltration, actually enters sewer systems. One of the main pathways is through infiltration, which happens when there are cracks in pipes, offset joints, damaged manholes, or deteriorated cleanouts. These are all points where groundwater or surface water can seep into the sewer system, especially if the pipes are old or poorly maintained. Then there's direct connection I want to highlight. Sometimes, sump pumps or roof drains are illegally tied into the sanitary sewer. These connections aren't meant to be there, and they allow stormwater or groundwater to flow directly into the system, which can cause serious problems down the line. Lastly, stormwater intrusion occurs through yard drains and downspouts that channel rainfall into the sewer system. Instead of going into the ground or proper stormwater facilities, all that rainwater gets funneled into the sewer, increasing flow and sometimes overwhelming the system. Understanding these pathways is crucial because they contribute to system overloads and can lead to issues like overflows or backups. This is why identifying and managing these entry points is so important for maintaining a healthy, efficient sewer system. Let's talk about why I really matters in our wastewater systems. First, treatment inefficiency. When there's too much I, it dilutes the sewage, which means the biological treatment processes become less effective. Essentially, the pollutant levels drop below the critical point needed for proper breakdown, making treatment less efficient overall. Next, system overload is a big concern. Excess I can cause sewer pipes and treatment plants to go beyond their designed capacity. This can lead to backups, overflows, and even environmental contamination, which are serious issues for both public health and our ecosystems. And finally, rising costs. When stormwater and I enter the system unnecessarily, it forces us to pump, process, and disinfect a lot of water that shouldn't be there in the first place. This extra work significantly increases treatment costs, putting a strain on resources that could be better used elsewhere. So, managing I isn't just about system maintenance. It directly impacts efficiency environmental safety, and costs. That's why it's such a crucial part of our overall strategy. Let's talk about the real-world impact of sanitary sewer overflows, or SSOs. When heavy rains hit, they cause inflow spikes that can quickly overwhelm even the most well-maintained systems, often within just a few hours. The consequences of these overflows are quite serious. SSOs release untreated sewage directly into streets, parks, and waterways, which not only creates a mess, but also poses health risks. These pathogens can spread through communities, leading to disease outbreaks. Moreover, our aquatic ecosystems suffer from the toxic loads introduced during these events, harming wildlife and water quality. The economic impact is also significant. Beach closures and fishing bans hurt local businesses and communities that depend on tourism and recreation. As an example, many municipalities report that between 60 to 80% of their SSOs are directly linked to inflow and infiltration, what we call I and I especially during storm events. This highlights how critical it is to manage inflow properly to prevent these damaging overflows. Let's take a closer look at some common entry points for inflow and infiltration in our communities. First, deteriorated manholes are a significant issue. When covers become loose and walls crack, they allow large amounts of stormwater to enter the sewer system, especially during heavy rains. Next, illegal sump pumps are another problem. These pumps often divert groundwater directly into sanitary sewers during wet weather, bypassing the intended stormwater management. Then we have roof drain connections. Sometimes, downspouts are connected to sanitary lines instead of proper storm drains, which can overload the system during storms. Additionally, aging infrastructure plays a major role. Pipes with offset joints or broken sections that are past their service life create gaps where water can seep in. It's also important to note that urban features like gravel bedding and permeable soils can actually guide groundwater toward these damaged pipes, increasing infiltration issues. All these factors contribute to the overall stress on our sewer systems and highlight the importance of maintenance and proper infrastructure planning. Now, let's look at how we can effectively detect and reduce inflow and infiltration, or I, in our sewer systems. First, we need to identify the problem areas. Flow monitoring is a key tool here. It helps us pinpoint those sewer sections that see abnormal wet weather increases, indicating where I might be entering the system. Next, we move on to field testing. Smoke testing is great for revealing illegal inflow connections, like sump pumps or roof drains that are improperly connected, and dye testing allows us to trace specific sources of inflow directly back to their origins. Once we've identified trouble spots, we conduct infrastructure inspections. Using CCTV cameras, we can locate pipe defects, cracks, and structural failures that could be contributing to I. Then, it's time for repairs. Sealing cracks, replacing damaged pipe sections, capping cleanouts, and disconnecting stormwater drains are all essential steps to reduce inflow and infiltration. Finally, engaging property owners plays a vital role. Private sewer lateral maintenance programs help prevent I at its source by encouraging property owners to keep their connections in good condition. Together, these steps form a comprehensive approach to managing I effectively and ensuring our sewer systems operate efficiently. Let's talk about the true cost of ignoring I, or inflow and infiltration, in our sewer systems. First, we see that ignoring these issues can lead to about a 40% increase in operating costs. This means higher energy use at treatment plants and more chemicals needed to treat the water, which adds up quickly. On top of that, there's the risk of environmental fines, over $1 million in penalties from agencies like the EPA, especially if permit violations or sewage spills occur due to unresolved I problems. We also see rate increases, around 30%, which means that our ratepayers end up paying more on their utility bills because the system has to work harder to handle the excess water. But the consequences go beyond just costs. Infrastructure can suffer serious damage. Soil erosion around pipes can cause sinkholes and even lead to collapses. The increased hydraulic load accelerates pipe deterioration and can shorten the lifespan of treatment plants and cause equipment to fail prematurely. And perhaps most concerning, there's a public health risk. Sewage backups into homes can happen when systems are overwhelmed, posing serious health hazards to residents. So, ignoring I&I doesn't just hurt the environment and the system, it directly impacts our costs, infrastructure integrity, and community safety. That's why addressing these issues proactively is so critical to the overall health of our water management systems. Managing I&I, or inflow and infiltration, is really about protecting our communities and keeping our sewer systems reliable. When we understand how infiltration, water seeping into the system, and inflow, water flowing in from sources like storm drains, work together, we can prevent system failures that could be costly and disruptive. It's also crucial for protecting the environment. By proactively detecting and repairing leaks and openings, we can reduce overflows that might pollute water bodies. This not only preserves water quality, but also helps safeguard aquatic ecosystems that are vital for our local environment. From a financial perspective, preventing I&I can save communities millions in treatment costs and infrastructure repairs. It's about being smart and proactive, so we don't face bigger expenses down the line. And of course, managing I&I isn't just the responsibility of utility companies. Everyone has a role: homeowners, businesses, and local governments alike. When we all work together, we can better control I&I and maintain a healthier environment for everyone. By making I&I management a priority, communities are investing in sustainable infrastructure, protecting public health, and ensuring we have clean water for generations to come. It's about creating a resilient, environmentally friendly future that benefits us all.